Hi friends, very good evening. Hello, how are you all? After 5 days gap, I hope everybody is doing well. How are the things going on? How many problems you have done in the last session? Hi Manse, very good evening. Smaranika, good evening. Radhika, hello. Abhishek, namaskar. Guruji, namaskar. Abhishek, namaskar. Yeah, any development last 4 to 5 days, how many problems you have done? Kam se kam 30 problems. Yogesh, very good evening. May I know the status of problems which you have done in the last session? I mean after the last session. Radhika, Smaranika, Mansi, Abhi, Yogi, may I know the status of the work you have done, the work you promoted in the last few days after the session. Jitesh, very good evening. Very good evening. Adina, good evening. How are you, Adina? Please message me number of problems you have done. Yogesh did 20 problems. Very good. Yogesh has done 20 problems. May I know about Adina, Jitesh, Yogesh, Abhishek, Radhika, Mansi. Abhishek said he has performed, he has done all the questions. Very great. Then Radhika, Samarnika, Mansi, your status of number of problems you have done. We will start, let me know the problems you have done. Radhika, 45 to 50 questions. Very good. Then Mansi, Smarnika, 60 questions. Well done, well done. Really super. Adina, 30. Jitesh, you have not said anything. How many problems you have done? Starting is not a problem, but finishing is a main problem. How many you have done? Mansi, 20 questions. Jitesh, 40. Well said. Goals of the class. Hi Yash, very good evening. Today we are focusing on topics of collision, and relevant problems. Radhika, you message me in between, I will clear it. And we discussed about 3 varieties of collision: elastic, inelastic, perfectly inelastic, followed by coefficient of restitution and the values of restitution for different collisions. A is equal to 1, A is equal to 0, A is equal to lying between 0 to 1 depending upon the type of collision. Now after that we had the formula for final velocities which we had in the last class. V1 is equal to m1 minus m2 by m1 plus m2 into u1 plus 2m2 by m1 plus m2 into u2. This is velocity of the first body after the collision. You mention your doubts. In between I will clear them. V2 is equal to 2m1 by m1 plus m2 into u1 plus m2 minus m1 by m1 plus m2 into u2. This was the discussion we had. Now, question from most students got wrong from the last CPP. Find the ratio of moments of inertia of two solid spheres of same momentum, but same moment of inertia here, same moment of inertia, densities in the ratio. Find the ratio of moments of inertia of two solid spheres having same mass but density is in the ratio 1:8. We know that the moment of inertia of a sphere I is equal to 2 by 5 mr square. I1 by I2 is equal to R1 by R2 whole square. Mentioned that they are having the equal mass. From a disk of radius capital and mass capital, a circular hole of diameter capital whose rim passes through the center is cut. This is a figure. The radius of the disk is equal to capital and given that mass is equal to capital M. In this, you made a circular hole of diameter this is the diameter cut. What is the Josna? No worry. After this, the center is cut. Find the moment of inertia of the remaining part of the disk about a perpendicular axis passing through the center. This is the original moment of inertia. And after removal, this is the moment of inertia of the removed part. Then we know that according to the parallel axis theorem, the moment of inertia of a body about any parallel axis I dash is given by I naught plus mr square. So, by applying this, you will be able to get the moment of inertia of the remaining part after the removal of this part. This is a hole where nothing is there. So, in that you have to apply the parallel axis theorem. I dash is nothing but original moment of inertia plus mr square. In this, whatever the mass you have removed, subtract from that, then you will be able to get the moment of inertia of the remaining part about this axis passing through its center and perpendicular to the plane of the disk. Next, problem number 1. There is a system of two blocks moving with velocities v1 and v2. v1 is given as 10 meter per second and v2 is given as 3 meter per second, and mention their masses. m1 is equal to 2 kg and m2 is equal to 5 kg. The surface on which they are moving is a smooth surface, and mention the spring constant K is equal to 1120 Newton per meter. Now, my requirement is find the maximum compression produced in the spring. Number 1, maximum compression produced in the hi Akshay, how are you? Compression produced in the spring. Yeah, we can do that question by the trick which you gave in the last class. That is readily already available. A small tool. Remove the area by remaining area into distance between the two centers. That will be the center of mass. But Radhika, here they have asked you to compute the moment of inertia. Whatever the trick I have given, that is for shift in center of mass. But in your doubt, you have asked moment of inertia. So from that you start moving that. Then when you are start rotating the disc, you are asked to find the moment of inertia. That trick will be applicable for center of mass shifting, but your problem is finding the moment of inertia. Fine Akshay, fine. Now this is a question. Remove the area by remaining area into distance between the two centers, and I have given that trick for Radhika for finding the shift in center of mass. Without any hesitation you can gear up, but in this problem they have asked if that remaining part is made to rotate, then what would be the moment of inertia of the remaining part. Very good. Now this is the problem I have given. We are dealing with the spring problems under collision concept. Here two blocks of masses M1 and M2 are moving on a smooth surface with corresponding velocities 10 meter per second and 3 meter per second. My requirement is find the x. This is nothing but maximum compression. That they have asked is maximum compression. X indicates compression that is produced in the spring due to the motion of the two blocks. Your time starts. Your time is running out. Today let us do as many problems as possible under collision concept. All the problems which we are discussing were given in previous JEE as well as NEET related with the springs. Springs already you know in the oscillations of 11th class. But apart from that, springs also play a vital role in collisions also. This is the problem. Anybody is coming out with options? Only Yogesh has declared his option as A. Your time runs out. Shall I start the explaining the problem? Shall I start the explanation of the problem? Now, when you observe when final velocity is equal, then maximum compression will occur. When final velocity is equal means the two blocks stick together and move together. Then when you observe the figure, this is Smarnika, very good. Smarnika came with some option C after Yogesh. These two people have declared answers. Abhishek, Adina came with A, Josna with B, Abhishek with C. Now let us see who is the perfect winner of today. This is figure 1 before collision. After collision, you know, this is M1. This spring is completely compressed. This is M2. They both are moving with a common velocity Vc. Then the relevant equation M1 U1 plus M2 U2 is equal to M1 plus M2 into Vc. So they are moving with the common velocity. As said by our friend, they are moving with common velocity implies they are moving with equal velocities. Then what happens, you know, spring got completely compressed between the two blocks. So from this step you have to find the common velocity Vc. Vc is equal to M1 U1 plus M2 U2 divided by M1 plus M2. That is first step. After getting common velocity Vc, you have to apply energy formula, kinetic energy formula. What is that? Kinetic energy of m1 is equal to half m1 u1 square. Here that is equal to half m1 v1 square plus half m2 v2 square is equal to half m1 plus m2 into vc square plus half kx square. So half cancel, half on either side. So kx square is equal to m1 v1 square plus m2 v2 square minus m1 plus m2 into vc square. Therefore, x is equal to root of m1 v1 square plus m2 v2 square minus m1 plus m2 into vc square by k. This is the regular procedure you are supposed to adapt. Finally, you will come out with the value equal to 1 by 4. That is nothing but 0.25. 0.25 is the right answer. Samanika, Abhishek, Mansi have declared that answer. This is regular procedure. For this I will give a shortcut also. So I think now you have got the idea how to solve this problem. For this, what is the shortcut you know? In collisions, you have a formula for loss of kinetic energy, half m1 m2 by m1 plus m2 into 1 minus e square into u1 minus u2 whole square. Whole square. This loss of kinetic energy as per the concept is converted as spring energy half kx square. Here E is called as coefficient of restitution whose value is equal to 0. This is a shortcut for finding the maximum compression in the spring. I hope everyone has got it. Now whoever declared options other than C, please correct your conceptual blocks. Please clear off your conceptual blocks. I am proceeding to the next problem. Am I? I am proceeding to the next problem. Now, the next problem is rubber ball dropped from a height of 5 meters on a plane and on bouncing it rises to 1.8 meter. That is 1.8 meter. Then the ball loses its velocity on bouncing by a factor of. I am narrating the problem. A rubber ball dropped from a height of 5 meters on a plane on bouncing rises to a height of 1.8 meter. Then ball loses its velocity on bouncing by a factor of. Your time starts. Your time starts. This time who is going to give the fastest, quickest, most accurate answer will be waiting eagerly for that answer. Rubber ball dropped from a plane, from a place onto a plane which is at a height of 5 meter, and as we know it bounces back by what height? 1.8 meter. Then ball loses its velocity on bouncing by a factor of attack. Your time is running. Josna, Radhika, Yogesh, Adina, Mansi, Jitesh. Adina declared her. Mansi came, Radhika came very fastly, very quickly. C, Abhishek came with C. Josna came with B. Still. Any other answers? Majority students have opted for option C. Only Josna have opted the option B. Now let us see who is the winner, either Josna or the team of C. Your time is up. Now I am coming into the action. A rubber ball is dropped from a height h1 5 meter. Here the two bodies in collision are, number 1 is ball, number 2 is floor. Ball parameters we take them as u1 and v1, and floor before collision and after collision it is at rest, therefore u2 is equal to 0, that is equal to v2. Now it rises to a height of 1.8 meter. So this height is given as 1.8 meter. Now the moment it hits the floor, you have to find the velocity at this point, that I will call it as u1. So the journey, the first journey is a freely falling body. First journey is a freely falling body. Therefore u1 is equal to root of 2g h1, that is equal to 2 into 10 into 5, that is equal to 10 meter per second. That is the value of u1. And second journey is a vertical projection. Its maximum height they have mentioned as 1.8 meter. So v1 is equal to root of 2g h2, that is equal to 2 into 10 into 1.8, that is equal to, tell me how much, 36 under root 6 meter per second. 6 meter per second, that is the velocity in the second journey, and u1 is the velocity in the first journey. Loss of velocity delta v is equal to loss of velocity, that is equal to 6 minus 10 or minus 6 plus 10, that is equal to 4 meter per second. Then factor they have asked. Factor is nothing but delta v by original velocity u1, that is nothing but 4 by 10. The factor is 2 by 5. It is Josna who analyzed the problem correctly. Very well said, Josna, well done. Keep it up. The winner of this problem is Josna. Her answer is equal to 2 by 5. Now I hope everyone has got the clarity in handling this problem. Downward journey is a free fall, upward journey is a vertically projection. Then by taking the velocities at the time of collision, one is u1 which is equal to root 2g h1, other is v1 which is equal to 6 meter per second. loss of velocity is minus 6 plus 10, 4 meter per second. They asked the factor. Factor is nothing but loss by original value 4 by 10, that is equal to 2 by 5. Shall I proceed? Got the clarity? Very good. Good. Now we are into the problem number 3. Ball dropped from a height of 10 meters. Of 40% energy is lost. Ball dropped from 10 meters. This is not of, this is if. If 40% of energy is lost on collision, then after collision the ball rebounds to a height of 10 meter, 8 meter, 60 meter, followed by 6 meter. Your time starts. Monsi came out very fastly with her answer as option A, 10 meter. Still I am waiting for few more options. Radhika came with option D. Monsi came with option A. Still any other answers? Vinayak Singh came with option D. Next, Josna came with option D. Next, this time many are opting D. Yogesh also came with option D. Josna is equal to E is equal to MGH. Very good. Josna is still extended. Smarnika option D. Very good. 6 meters is a correct option. For example, it is dropped from a height of, say for example, 10 meters. This is point A. And after that 40% energy is lost. With only 60%, it is able to rise to a height of H2. So initial energy E1 means energy at A. M into G is 10, H is 10, 100 M. Loss 40%. 40% of energy is lost, means 40 M. Balance energy 60 M, that is equal to mg H2. Mm cancel. H2 is equal to 6 meter. Everyone has done very good. Fantastic. This is the solution given. H2 is equal to 6 meter. Problem number 4. Answer is 60. 6 meter. Rises to a height of 6 meters. Very good. Already problem number 4 is eagerly waiting for you. Gear up very fastly. A nucleus of mass number capital A at a rest emits alpha particle with a speed v. Then recoil speed of daughter nucleus is how much? Recoil speed of daughter nucleus is how much? This is a problem. Once again I am narrating. A nucleus, what is recoil speed? Going back speed is called as recoil. If you fire a gun, bullet will be moving in the forward direction. That gun will be moving in the backward direction with some speed. That speed with which the particle is moving back is called as a recoil speed. If you play the carom board, there are no coins except striker. You just push the striker, it hits the frame and come back. That coming back velocity is called as a recoil velocity. So already answers they are coming out. Josna with A, Mansi with A, Radhika with A, Smarnika with A, Yogesh with A. Very, very enthusiastic. Still I am waiting a few more options. Still I am waiting for correct option. Many options already came. I am waiting for the correct option. Akshay also came with option A. Many are opting A. Why? I don't understand. I am eagerly waiting. Who will give the appropriate answer? Who will give the appropriate answer? I am eagerly waiting. Abhishek also came with A. Fantastic. Option A is the best option. Super. Everyone has unanimously opted for A. Mass number A at a rest. Josna came out with 4V by A minus 4. She already gave the solution also. Very good. Recoil implies reverse direction only. You need not worry. They use the word recoil. That recoil implies direction is opposite. Option Mansi, yeah, came out with another option. 4V by A plus 4. Still I am waiting. Few more answers may come to judge the concept. See, M1 is equal to A, U1 is equal to 0, emits alpha particles with a speed EV. M2 is nothing but alpha particle. Alpha particle is nothing but helium nucleus. Helium nucleus 2He4. That is the value. Then when 4 units are gone away from A, the remaining mass A minus 4, and you are asked to find the recoil velocity. That is nothing but V2 is equal to how much? Applying law of conservation of linear momentum, you will come out with 4V divided by A minus 4. Now it is the time of previous contest question. The first line in the Lyman series has a wavelength lambda. The wavelength in the first line in the Bomber series, option A 2 by 9 into lambda, option B 9 by 2 into lambda, option C 5 by 27 into lambda, option D 27 by 5 into lambda, and the correct option is given by Indrajit. Give him a big clap. He is eligible for getting one atom session free. Indrajit, lot of congratulations to you. Keep the spirit continuously for a long time and try to win few more atom sessions free. Now it is the time of contest question. Now it is the time of contest question. A solid sphere is moving and it makes an elastic collision with another stationary sphere of half of its radius. After collision, it comes to rest. Then the ratio of the densities of materials of second sphere to that of the first sphere. Once again I am narrating the problem. A solid sphere is moving and it makes an elastic collision with another stationary sphere of half of its own radius. After collision, it comes to rest. The ratio of the densities of the materials of the second sphere to that of the first sphere. Now we are into the problem number 5. collision between A and B is perfectly elastic, then find maximum energy stored in the spring in joules is. Collision between A and B is perfectly elastic. My requirement is find the maximum energy stored in the spring in joules. Find the maximum energy stored in the spring in joules. Collision between A and B is perfectly elastic, and find maximum energy stored in the spring in joules. This is the problem. Your time starts. Monsi very fastly came out with the option C. Still I am waiting for few more options. Your time is running. Gear up, go ahead fastly. Yogesh came with option B, and Adina and Abhishek came with option C. They are coming out with option C. Still I am waiting. Yogesh came with option B, fantastic, 16 joule. And Pratap Singh, Smarnik option A. Very nice. It is this time it is a mixed response. Nobody is insisting on a single answer. Majority number is not having for any single option. Everyone is taking their own options. Really very enthusiastic. Yeah. Still I am waiting for few more seconds. Our time is up. Now, when you analyze the problem, here B and C form a system. Nothing is said about B and C. You have to feel they are at rest condition. Here the projectile means the body that is used for collision is called as a projectile body. From the figure, the projectile body is 3 kg mass. It is moving with a velocity of 2 meter per second, and it hits B. It is very clearly mentioned collision is perfectly elastic. See, I am taking a ball of mass m1 moving with a velocity u1, colliding with another body m2, move at a rest means u2 is equal to 0. After collision, if m1 is equal to m2 implies bodies are identical, you will find exchange of velocities. You mean A will take the velocity of B. B is already at rest. Therefore, after collision, velocity of A is equal to 0 and velocity of B is equal to 2 meter per second. That is the velocity of the B, which is equal to 2 meter per second. Now, when you observe this, you are asked to find the maximum energy stored in the spring in joules. So, when you this m1 u1 plus m2 u2 is equal to m1 v1 plus m2 v2. you can apply this and you can find the common velocity. Or directly I have given a shortcut. Loss of kinetic energy delta K is the gain in spring energy, that is nothing but half kx square. Loss of kinetic energy, already you are having this equation, half into mb into mc by mb plus mc into vb minus vc whole square. From this you will come out with the correct answer as 4 joule. 4 joule is a perfect answer. Loss in kinetic energy will be transferred as spring energy. Loss of kinetic energy is half m1 m2 means mb mc by mb plus mc into v1 u1 minus u2 whole square means vb minus vc whole square into 1 minus e square, e being 0. This entire loss will be converted as kinetic energy, converted as half kx square, that is spring energy, which will be equal to 4 joule. Fantastic, the all winners who put the option A, fantastic performance. Shall I proceed for the next problem? If you message me clear, then I will go to the next problem. Monsi came out with clear sir, fantastic. Now I am giving one more problem. Be ready. A shell is fired from a cannon with velocity of v meter per second at an angle theta with the horizontal at the highest point, you mean at h max, it explodes into two pieces of equal masses. One of the pieces retraces its path to the cannon, then speed of the other piece immediately after explosion. Option A root 3 by 2 v cos theta. Option B 3v cos theta. Option C 2v cos theta. Option D v cos theta. I am narrating the problem. A shell is fired from a cannon with a velocity of v meter per second at an angle theta with the horizontal. At a maximum height, it explodes into two pieces of equal masses. One of the two pieces retraces its path to the cannon. Then speed of the other piece immediately after explosion. Option A root 3 by 2 v cos theta. Option B 3v cos theta. Option C 2v cos theta. Option D, V cos theta. Your time starts. Fantastic summary of the class. We started with the collisions and we have done numerical problems related to the springs in collision, elastic, inelastic, perfectly inelastic. So, this is the session in which we dealt with the problems. I have given a set of fantastic 10 problems, try to solve them, and apart from this gear up with other problem. Thank you for joining. Have a nice day. Bye friends. Happy day.